Hi, today we are going to learn about the basics of electrical substation. Before understanding what is electrical substation, we need to understand what is an electrical system. So, an electrical system is primarily consists of a generation, transmission, and distribution. Right, and electrical substation is an arrangement where voltage is either step up or step down, or current is distributed to the different loads. These arrangements can be part of either generation, transmission, or distribution system. Now, in the picture below, you can see the generation, transmission, and later part it is distribution. So generation generally happens at 11 kV, and transmission generally done on different voltage level like 66, 132, 220 kV or 400 kV. So there is a need of step up this voltage from 11 kV to 220 or 132 or 400 kV. Again, in the case of distribution, this voltage is again step down to different distribution voltage level, maybe 33 kV, 6.6, 11 kV, or 415 volt final distribution. So in this case, we need step up and step down. The arrangement where the step up and step down is done is called the substation. There are two types of substations. So one is a step up, step down, or another is indoor and outdoor. Here, this is a outdoor substation, and this one is an indoor substation. Major components in a substations are transformer, circuit breaker, switch gears, busbar, and protection system. Out of these, protection system is the most important aspect of any substation. And let us understand why it is the most important. The primary reason why protection system is introduced in a substation is to protect either the equipments or the personnel working there. Let us take an example. One 160 MVA transformer will cost something around 2.5 crore, and if we don't use any protection system into it, then we are allowing it to damage when there will be a fault. Whereas the cost of a protection system could be something around 20 to 25 lakhs. Now, in case of a fault, maybe the protection system will get damaged, but the it will save the equipment, which cost 2.5 crore approx. It means it is saving us from the potential loss. It also save the downtime. If in case of the transformer got damaged, then the downtime would be very high as compared to the protection system. So it also increases the reliability of the system, and at the same time, it also saves the persons who are operating there from getting shock and kind of things like arc flashes. Now, let us take an example of real life application. This is a 132 by 11 kV substation. The first equipment is LA. LA is lightning arrestor. This is the symbol of an LA. We will just have an overview of the components and how they look like, because as a design engineer, one need to understand these symbols and draw a meaningful conclusion out of these diagrams and symbols. So second is PT, potential transformer. Look at the symbol. This is the symbol of a potential transformer, and the secondary side there are two circles. So which means there are two core. The core one is 0.2 class, and core 2 is again 0.2 class. So it means they are all metering city. We'll come to these details in subsequent videos. Today we are going for a very simple basics of what is there in the substation. Next part is city. City consists of here in this case there are two core 1 and core 2, and both are metering city. Next is isolator. Isolator is there to isolate the rest of the circuit from the incoming, maybe the grid. Because it is a 132 kV substation, it is a grid substation here. Then PT2, the first PT was there, which was for the state electricity board to use, and this city is for the substation to use. So in this PT, there are two core. One is metering core, and another is protection core. Uh, See, the class is 3P. This is how the protection core is represented. And next part is again the city. In this case, there are three core in this city. Two. Core 2 and core 3 are protection core, and core 1 is the metering core. All these three signals are entering into this box. This is a relay, and also from the PT, these two connection is coming here in the relay. So this relay is getting input from CT as well as from the PT. With this input voltage and current inputs, it will calculate by itself different protection parameters. And there are two relay, MICOM P141 and MICOM P442. These two relays are used to get all the protections. These are ANSI codes 5050 and 51. We'll understand in detail the meaning of each of these codes in subsequent videos. Later, it there is a circuit breaker to discontinue the circuit if required, and then another isolator. So upper part is called incoming bay, and this part is called outgoing bay. This dotted line and this dotted line, above this dotted line, that is called incoming bay, and below this dotted line, this is called outgoing bay. Now in between there is bus bar. Here it is 1250 ampere, 132 kilovolt, 40 kiloampere ACSR twin zebra conductor. We'll later on understand what is the meaning of ACSR twin zebra conductor. And uh, after that, there is again an isolator. Then PT, again the PT has two core. One is metering core, one is protection core. This is the same PT, PT3. It was there above. Again, there is a CT. CT has three core: core one, core two, core three. Core two and core three and protection core, and core one is the metering core. Similarly, here also there is a relay with lot of different protections. We'll understand the meaning of these protections later on. See, the delay number is different because the protection requirement is different in this case. And after that city, there is a circuit breaker, then there is a LA. This is the last LA because uh, in a substation, so when the incoming line is entering the substations, there is a LA, and when the line is entering towards the indoor substation, there is an LA. So after that, after this LA, the line is entering to the indoor part of the substations. Let us see. So LA is just above this transformer, and after this transformer, there is long line. This line is representing bus duct. From this bus duct, it is entering to the 11 kV HT switchboard, which is inside the building. This dotted line again, this dotted line above the dotted line, it is this is outdoor part of the substation, and inside this dotted line, this is the indoor part of the substation. Look at it. This transformer is 132 by 11.5 kV transformer, which means this is a one step down step down substation with 132 by 11 kV voltage step down. So what we have understood today is what is an electrical substation. Electrical substation is an arrangement where we can step up or step down the voltages, or we use current to be distributed in the different load segment. Type of substations, there are primarily two types of substations. One is step down, step up, step down substations, or second is indoor or outdoor substations. Major components of the substations are like your circuit breaker, transformer, switchgear, and of course the protection element is very important because it either protects the equipment which are very costly, or it protects the life. And we have also seen a small real life example of SLD of 132 by 11 kV substations, and major components in that we have seen that there are CTPTs into it, and CTPT comes with different codes, protection codes and metering codes. We will learn more about these components in detail in subsequent videos. Hope this video was useful to you. Thank you.